Okay, so another method to determine order of reaction is using graph. So there are two ways to determine order of reaction using graph. So the first graph is graph of concentration versus time. So from graph concentration versus time, we need to find several values of half-life. Okay, so we plot a graph concentration versus time, and then we find several value of half-life. Okay, so this is the first example. So from the graph, we need to find y-intercept. So y-intercept determine initial concentration. So from this graph, we know that the initial concentration is 0.2. Half-life means that the time taken from the initial concentration to become half. So from 0.2 to 0.1. So the time taken is starting from here up until this point. So we get the value is 32.5. Okay, so that is the first half-life. The time taken for the initial to become half. Second half-life is from 0.1 to become half. Okay, second half-life kita akan kira daripada 0.1 until half. So the half will be 0.05. So 0.1 until it become half to become 0.05. So the time taken to become from 0.1 to become 0.05 is 17.5 second. And then the last one, third half-life, 0.05 to be reduced to 0.025. So the time taken is 7.5. So again, from graph concentration versus time, we need to find several values of half-life, at least two. Okay, so if the value of half-life is decreasing, so it means that this is the zero order reaction. So from this value, we can conclude that this is a zero order reaction. So half-life decreases with decreasing concentration. So this is zero order reaction. Okay, if it's a first order reaction, okay, similar like before, you plot a graph concentration versus time. So you find y-intercept. So this is the initial concentration. So the time taken from initial to become half is 7 seconds. Okay, and then second half-life. So from 0.1 until 0.05. So also 7 seconds. So the third half-life is also 7 seconds. So if the value of half-life is constant, does not change, first, second and third, so it means that this is the first order reaction. Okay. Okay, for second order reaction, okay, similar like before, you need to find several value of half-life, at least two. Okay. So we can see that the value of half-life is increasing. If the value of half-life is increasing, it means that this is a second order reaction. Okay, so as the summary, you can see here. So zero order half-life decreases. First order half-life is constant, does not change. For second order, half-life will be increases. Okay, so we plot a graph, concentration versus time, and we find several value of half-life, at least two. Okay, next we look at example. Okay, so the question asks you to plot a graph, concentration versus time, and then deduce order. So when the question asks you to plot the graph concentration versus time and then deduce the order of reaction, it means that you need to find several value of half-life. Okay, so you find y-intercept first. So this is your y-intercept. So this is the initial concentration. Okay, 180. So to become half, 90. So 180 divided by 2 is 90. So this is the first half-life. So the time taken here is 20. So label half-life first. Okay. So from 90 to become 45. So 45 is somewhere around here. So we take starting from here up until this point. So this is second half-life. Okay, so the first half-life is 20 minutes. Second half-life 40 minus with 20 is also 20 minutes. So starting from here up until here 20 minutes. So the value of half-life does not change, remain the same. So it means that this is the first order reaction. Okay, so based on the value, so the value does not change. So this is the first order reaction. So if you want to find rate constant, okay, we can use this formula. So for the first order reaction, half-life is equal to ln 2 over K. So K is equal to ln 2 over half-life. So half-life here is referring to first half-life. So from the original initial to become half. So divided by 20 minutes. So you will get value of rate constant. Okay, another method to determine order of reaction is using integrated rate equation. Okay, so given data here, so you need to plot 3 different graphs according to integrated rate law. So for zero order, you are going to plot the graph concentration versus with time. Okay, so first order, you are going to plot the graph ln concentration versus with time. So for second order, 1 over concentration versus with time. Okay, so different order, different y-axis. Okay, and then when you learn something, there is no unit. Okay, you learn the concentration, there is no unit. 1 over concentration, the unit will become molar negative 1. Okay, so when you plot these 3 graphs, we would like to find which graph will produce linear graph. Okay, we don't want to take a curve graph. We want to look at linear graph. So, daripada tiga-tiga ni, bila kita plotkan, kita akan dapat salah satu yang linear. Lagi dua tu, dia akan jadi curve. Okay, bila kita plotkan ketiga-tiga graph ni, so graph yang memberikan linear is graph of 1 over concentration versus time. So, it means that this is a second order reaction. So, second order reaction, the plot of 1 over concentration versus with time produces straight line. Okay, so it means that dia adalah second order reaction. So dia bukan first, dia bukan zero order. Okay, katakanlah kita plot tiga-tiga graph tu, yang straight line tu dekat zero order. So dia adalah zero order reaction lah, order dia. Okay, sebab kita nak cari yang straight line. Okay, okay. But in exam, you don't have time to plot 3 different graph. Kita tak ada masa nak plot 3 different graph. So how the question look like in exam? So normally the question look like this. Applying graph method, verify that the dissociation of compound F is first order reaction. So it's already mentioned it's a first order reaction. So when it is a first order reaction, you need to use integrated rate law for the first order reaction. So the first order reaction, the integrated rate law is look like this. Ln F is equal to negative KT plus with C. So you are going to plot graph ln F versus with time. So you need to press calculator. So ln this concentration. Okay. And then so this is the value. Okay, so you need to press calculator. Okay, you need to find the value of ln F. Okay. And then when you plot, definitely you will get a straight line because the question already mentioned it is a first order reaction. So definitely you will get a straight line. So you need to make a conclusion. First order reaction, we plot the graph ln F versus with time produces straight line. So it means that this is a first order reaction. Okay.